So now we're going to look at taking derivatives of functions of two variables, and we call these partial derivatives. So partial derivative of fy with respect to x, written fx, is the derivative of f of x, where y is treated as a constant and f of xy is considered a function of x alone. So we are going to take the derivative of these functions. When we take the derivative of these functions, we consider one variable the actual variable, and the other variable we pretend is a constant, and we use the rules for constants when we take the derivatives. So if we're taking it with respect to x, they write it as fx, or there's a few other notations. They write it, this is like delta z over delta x, if they define my function as z equals f of xy, or they could write it in the other notation where it's like delta over delta x of f of xy. So the most common notation we will use in this class is f of x. This one shows up occasionally on the online homework. So it says find f of x. So the partial derivative with respect to x is what we're saying. So what we do to find that is we take the derivative of the x term and we treat the y term as a constant. So we know if y here is multiplied by 5x cubed and that's a constant, then when we're taking the derivative of it, we just leave it there. Like think about when we have f of x equals like 2x squared. So what we do is we really leave the constant and then we multiply it by the derivative of x squared, which is 2x. So in this case, when we're taking the partial derivative with respect, we're going to leave like only the 5y squared because those are my constants. And then I'm going to multiply this by the derivative of x cubed, which is 3x squared. Okay, and I'm just pretending this is a constant, like that's a number and it just stays there. And so when I take that derivative and simplify, I get 5 times 3, which is 15x squared y squared. Okay, and this is the partial derivative of f with respect to x. Now we can do the same thing for the partial derivative with respect to y. So if we have the partial derivative of f of x y with respect to y, we write it as f with a sub y. And that's the derivative of f of xy, where x is treated now as a constant. And f of xy is considered a function of y alone. Okay, and again, we have other notations. These are our two other possible notations that you may see, meaning that you want to treat x as a constant and y as the variable. So again, when I'm taking this partial with respect to y, 5x cubed is a constant. So because it's in front of there, we're just going to leave that in front, and then we're going to multiply by the derivative of y squared, which is 2y. And then we can simplify, we can multiply our 5 times 2, which is 10x cubed y. So we're going to look at a few examples because depending how they write the function, we treat it differently. Okay, before I do this one, I want to do this one here, and then we'll come back to those other ones. Okay, so we're going to find the partial with respect to x and the partial with respect to y for this function. So the partial with respect to x. Okay, so x is my variable and y is considered a constant. So when I have the constant times the variable x, again, we're really just leaving it there and multiplying this by the derivative of x squared, which is 2x. Okay, and you can put the y in front if you're more comfortable with that. It doesn't really matter. So same thing here. I'm really taking the derivative of minus 2x, which is minus 2, and then I'm leaving that constant y squared here. Okay, plus the derivative of 5x is just 5. Now, y, remember, is a constant, so the derivative of negative 75y is just like if you were taking the derivative of 10, and that's 0, and the derivative of 10 is 0. Okay, and the only reason, again, is because we're treating x in this case as the variable, and y is a constant. So we're pretending y is just some number. And so our answer is 10xy minus 2y squared plus 5. And that's the derivative of f of xy with respect to x. Let me do the f of y. Okay, so it's derivative with respect to y. So now, in this case, x is a constant. Okay, and then the y is the variable. So again, if we have x times the y, what we do is we just leave that x term and we multiply by the derivative of y, which is 1 minus, okay, so 2x is going to stay there because I have a y times 2y. Okay, again, because they're just like a number in front. Okay, but now I have 5x, which is, you can pretend like it's just 5, it's a constant, and that derivative is 0. Okay, 75y is minus 75, and then the derivative of 10 again is, of course, plus 0. So if we simplify this, we get 5x squared minus 4xy minus 75. And then this is my partial with respect to y. Okay, so let's look at a few a little bit harder examples. So again, we want the partial with respect to x and the partial with respect to y. So again, for this one, x is the variable. Y is constant. So for this one, we have 4 times the quantity, 4x plus 3y minus 5 to the 8th. So this one, again, we have something with our variable to the 8. So it's kind of like if we were doing it in terms of one variable, this is similar to 4 times x, like a function of x. We'll just say like x squared minus 2 to the 8. It's like that idea. So when I take the derivative of this, because I have a variable inside of exponent, I have to use that chain rule. Okay, and you want to review that because it's been a while since we used that. So when we do the chain rule again, we take the derivative of that outside piece. So again, the outside piece is something to the 8th power. So we multiply this by 8. We keep the inside the same. Okay, so remember when we were doing this one, we would do like 4 times 8, and then we keep the inside the same. Okay, and this becomes 7 because we subtract 1 from it. And then we multiply by the derivative of that inside, which is 2x. So we're going to multiply by the derivative of this inside. So again, x is my variable, y is my constant. So the derivative of 4x is just 4. 3y, well, that's a constant, so that's really 0. And minus 5 is also 0. So this becomes, let's see, 32, 4x plus 3y minus 5 to the 7th times 4. And then I can multiply my 32 times 4 because they both don't have exponents on it. And so we get 128, 4x plus 3y minus 5 to the 7th. And I just kind of as a reminder, the derivative for that chain rule is the derivative of the outside, keep the inside the same, and then we multiply by the derivative of the inside. So let's look at the partial for y. So we would have f of y. Again, in this case, we say y is the variable and x is constant. So again, our variable is inside of an exponent, so I have to use chain rule again. So it's kind of the same idea. We bring down, the outside's going to be the same. We bring down that exponent. We keep the inside the same. Okay, we subtract 1 because we're taking the derivative of something to the 8th power. and then we multiply by the derivative of the inside. So 4x is a constant, plus 3y is 3, and then minus 5 is also a constant. And so we get 32. This stays the same to the 7th. Okay, and just a reminder, you cannot distribute this in because it has an exponent and order of operations. We always do exponents before multiplying. And then times 3, and then we can multiply our 32 times 3 because they don't have exponents. So we get 96, and then 4x plus 3y minus 5 to the 7th. So that's how we do this with the chain rule. One thing, if like the chain rule with this confuses you, you can use that technique that one of the professors shows in the other videos, is you let u equals that inside. And then you make this 4u to the 8th. And then you're going to multiply by the derivative of u. So when you take the derivative of this, so again, if I do kind of with respect to x, initially it's not going to matter because we're going to take the derivative of this. So you take the derivative of this, which is 32u to the 7th. And then remember, you have to multiply by the derivative of that u for chain rule. And u prime, though, again, this would be in terms of x if we do the partial with respect to x. So then again, I treat anything with a y as a constant. So the derivative with respect to x would be 4. And then again, this is plus 0 minus 0. So this would just be 4. And so this would be like 32u to the 7th times 4, which is 128 u to the 7th, and then you have to substitute your u back in, which is the 4x plus 3y minus 5. Okay. And then if you did the partial with respect to y, it would be the same thing. You would be saying that you're starting with 4u to the 8th, so it would still be 32u to the 7th times u prime, but now your derivative of your inside, so I would say like uy, would just be, this is 0, so -3 minus 0, so it would just be -3. And I think, oh, I changed the problem here, plus y, so +3. And so again, this would be 32. I would plug in my u and then multiply by 3. So I don't know if that helps, but it might help for this one to see that you're using chain rule and how to do it with the inside being a variable of 2 variables. Okay, and so one last one. So f of xy is equal to e to xy squared. So just we need to remember when we had the derivative of e to some function, remember it is itself, and then we multiply by the derivative of the exponent. So again, the derivative of the exponent is just whether it's with respect to x or with respect to y. So we would take the partial of f would be e is itself, and then we would multiply by, I'm going to write it as that d delta x of this inside. So we take the derivative of that inside, which we're going to do it with respect to x. So x is my variable, y is a constant. So the derivative of x is 1, and then it would just be y squared because that's my constant times it. And so this is y squared e x to the y squared for my partial with respect to x. And then my partial with respect to y, okay, so again, e is itself, but then I would be taking the derivative of that inside with respect to y. And so when I do that, x is a constant. So again, I'm just going to leave that in front and then multiply by the derivative of y squared, which is 2y. And so I just like to put this in front. It's my preference. It really doesn't matter, but how I always write it. So I would have 2xy e to the xy squared. Okay. So that's our derivative, our partial derivatives. And let me know if you have any questions on them.